Okay, so the first thing that I need you guys to do, these two slides right here, you can use the extra sheet that I printed out because the ones on your stapled packet are too small, and also my graph is not quite right on that. So the first thing we're going to do is fill in this table. So we're just going to use that unit circle that we've got, and I'm going to use my unit circle to find sine of 0, right? I'm plugging in 0 here. So I would go to 0 on my unit circle. I'm going to find my sine value, which is my y coordinate. What is it? It is 0, right? And I'm going to fill that in. And then I'll do sine of 30. What is sine of 30? 1/2. Okay? So I want you to use your unit circle to fill in the rest of that table right there. And I'm going to freeze it so you can't see what I'm doing. I'm going to fill mine in too. Alright, so I think most of you are pretty close to done. Maybe may skip down to cosine already. What were you basically doing as you wrote those values down? Just looking at like those y coordinates all the way around the circle, right? You were just going all the way around the circle and listing all those unit circle values. So what we're going to do is we're going to graph those, but we're not going to graph them on the unit circle. We're going to graph them on like an x, y coordinate plane. Okay? So let's label a couple things here. I have put in some dotted lines right here. Those dotted lines, this dotted line you can see pretty clearly is at 0.5. So that is your 1/2 line. Then the next one up, that is at square root of 2 over 2. What do you guys think the next one is? That next dotted line. Square root of 3 over 2. Right there. And then I put a dotted line at 1. Right there. So these are our unit circle values. I put those dotted lines there because it's like square root of 2 over 2 is 0.7 something. That allows us to graph this a little bit easier. Okay, so here is what we are going to do. We are going to graph these points on this coordinate plane. So 0, 0 goes right here. We'll put a dot right there. Okay, then we will have 30 degrees, 1/2. So 30 degrees is right here. We got 1/2. We're looking right here. Then 45 degrees is square root of 2 over 2. 60 degrees is square root of 3 over 2. And so on. Okay? I'm going to freeze my screen. I want you guys to graph all of those points, every single one of them there. make sure you realize, like I counted by 15 on that x-axis. Is 15 or 75, are those on the unit circle? They are not. We skipped those. So like, just to make sure everybody's doing it right. This next one right here is 90 and 1. So make sure you go to 90 and 1. So you kind of have these little gaps right here. Right there, because it's not just like each line, because we're skipping 15 and we're skipping 75, because those are not on the unit circle. Alright, look at your neighbors, see what theirs looks like. See if it looks like yours. I'm seeing a little bit of variation. A little of them. A little wild looking. Over here. Okay. Here's what mine looks like. They're a little hard to see there. Alright, I saw a couple of you that did not do really like negatives over here. When you're graphing negatives, I should have mentioned that these are your negatives. Here is your, I could have done this also. Might should have done this. This is the x-axis right here, which is, I think, pretty clear. But the fact that this is the y-axis right here might be a little hard to see. So like this is negative 1/2. This is negative square root of 2 over 2. This is negative square root of 3 over 2, and that's negative 1 right there. So when you get past 180 right here, you're going to start graphing like 210. You're going to go over to 210, and you got to go down to 1/2. Or negative 1/2 right there. So if we draw in our line to trace this out, you should have a graph that looks like this. Now, let's talk about this in the unit circle, because this is the main reason that we even worry about teaching the unit circle, because the unit circle is helpful if you don't have a calculator, but that's not a good argument anymore, right? So, as I go around, I started right here at 0, and I went around to 360, right? What would happen if I kept going past 360? What's going to happen to my numbers? Are they going to be any different than they were the first time around? No. They're just going to start repeating over and over and over and over again, right? It's just going to happen, the same. I could go backwards. I could do negative angles. It's still those same numbers over and over and over and over again. So I'm going to pull up Desmos, and this is our graph of sine x. So let me pull up Desmos over here, And I'm going to have to change a couple things because I've got a mess. Let's just go. I gotta definitely go back to the grid. I need to go from 0 to 360 if I'm going to do degrees. And what's the lowest number that's ever on the unit circle? What's like the lowest point on it? -1. What's the highest point? +1. So I'm going to do like -2 to +2 here on my y-axis so that I don't have a lot of extra stuff there. And so if I graph y equals sine x, you can see that looks like what we just graphed, right? But look what happens if I drag this over past 300. If I keep on going, if I put in 1150, the graph's still there, right? It keeps on going because this just keeps going around and around and around and around. You could go around a gazillion times, right? I could go to the negative values over here. I could go to negative angles, and the graph just keeps on going and going and going. If I want to zoom out, you can see it's just a curve that keeps on going over and over and over and over and over again. Okay? So I think this is so cool. Because trig, whenever you first started learning it, started with just triangles, right? It was just triangles, and the biggest angle we ever looked at was 90 degrees because it was for right triangles. And then we took it and we put it on the circle, and it seemed crazy, and we weren't like even sure what in the world we were up to trying to do this, right? We took these circle values. Then we took these circles and we put them on just like the XY coordinate plane. We took these values from the circle, and it has given us a curved graph. So whenever it gives us this wave graph, there are all kinds of things that this can be used for. This wavy graph right here, if I zoom back in a little bit, it can be used, for example, I've mentioned this a couple times, but like it can be used for high tide and low tide. So at a certain time you've got high tide, and then a certain time you've got low tide, and you can use that to predict. When I have pre-calculus, sometimes I have them do a project. You can go to the NOAA website, which is the, oh gosh, what's that even stand for? It's the weather, like the government's weather website. And you can go there, and they have stations all over the U.S. where any coast, you can pick wherever you're going. So if you're going to Myrtle Beach, or if you're going to, somewhere in Florida, if you're going somewhere in California, anywhere that's on the coast, you can pick it, and it will tell you high tide, low tide, and it will show you the graph, and it will look like a sine function, and it will give you the predictions for the future. Now, high tide, low tide is not perfect because weather conditions are going to affect it. All kinds of things can affect high tide, low tide. So it might not be a perfect sine graph, but you can use the sine graph to predict when it's going to be high tide and when it's going to be low tide in the future. So it's kind of cool. You can use this for things like the hours of daylight. I've talked about that. You could use this for sound waves, for radio waves, for all kinds of different things that you might want to study. So we have gone from something that was only used for right triangles to something that has a lot of different uses in the real world that seem like they have nothing to do with a triangle, right? If I asked you if ocean tides had anything to do with right triangles, you would probably say no. But you can use sine graphs to model those, which to me is so crazy and so cool because math just fits all together and sort of describes the universe, and it's just so cool. So let's look at cosine. All right, so cosine is going to be that second graph. I want you guys to do the same thing for cosine. All right, fill in your values for cosine and graph those on that coordinate plane. I'm going to freeze my screen again so that you can't copy me.
really does like you get the ham and then
Pretty close.
pretty close.
There's a lot of extra dots on yours.
Well,
That
just
Yeah.
split really hard.
so this looks pretty similar, right? You should have noticed in your table, it's all the same numbers over and over again, right? We're getting all the same numbers over and over again. It's just we're kind of like starting in a different place this time. So the big difference in our sine graph and our cosine graph is that sine of 0 is 0, but cosine of 0 is 1. So where my sine graph sort of started like here and went up and down, the cosine graph has a y-intercept there at the highest point, right? So if we look over at Desmos at this, real quick, if I graph, let's see, I'm going to do that for a second. If I graph y equals cosine of x, cosine of x, if I just give you these, like, if I give you that alone versus giving you this one alone, can you guys tell the difference? They look really hardly any different at all. Not really, right? Like, they look just like the same curve that keeps on going. So, the difference is, if I put them side by side, you can see the difference, right? The difference is, for sine, which is my red graph right there, for that red graph, my y-intercept is at 0, 0, because sine of 0 is 0. So, this graph right here is different than the blue, where cosine of 0 is 1. So they have sort of different starting points, but they follow this exact same pattern, right? If we wanted to, we could just like shift one of these over, and they would be on top of each other, right? So whenever it comes to using these in the real world, whenever we're using them to model situations, it really doesn't matter if we use sine or cosine. There are going to be some, for us, we don't have to worry about shifting these left or right, so there are going to be some that we might want to use sine versus cosine for, but in reality, we could really use either one to model these situations. So let's talk about a few key features of, the screen went off. What happened to it? Okay, there we go. All right, so let's talk about a few key features of these graphs right here. And as far as like graphing these by hand, you're not going to have to do that. We can use Desmos on the whole. We're primarily going to look at these on Desmos and by their equations. But that activity was kind of to help you see that these unit circle values that we have on our circle are where these values on our trig function come from. So, sinusoidal graphs, this fancy word right here, sinusoidal, is just talking about sine and cosine graphs. So, sinusoidal just means sine and cosine graphs. And there are 3 characteristics that we have to know about in this class. There are some others that we are not required to look at because this is just an introductory level to this stuff right here. So later you may see other stuff, but in this class we only have to know about 3 things. The first one that we must know about is called the midline. Okay, the midline of a sinusoidal graph, or a sine or a cosine function, is the horizontal line midway between the maximum and minimum values of the function. So I just have sine of x graphed right here, the basic sine graphed. What is the midline for this? It's y equals 0. It's just that x-axis, right? So right here, this is my midline right here. So let's draw that in and label it. Actually, let me go back. Let me label it over here. Midline. Okay. Now, on other functions that have been shifted, that's not always at the x-axis, but it is if you just have the basic sine graph. Okay? We also have something called amplitude. Okay? So sine graphs have amplitudes. The amplitude is the distance from the midline to a maximum or a minimum point. So from the midline right here up to the maximum point. That is called our amplitude. So it tells us how tall our graph goes. It might just go up 1 like it does here, or it could go up to 1,000. And we'll see how we can change the graph and do those things on Monday. The amplitude could also be from the midline to the minimum point, because that should be the same distance, right? From the midline to the maximum, midline to the minimum should be the same distance. So it could be either one of those. Okay? And the last thing that we have to know about these graphs is the period of the graph. The period is the length of one complete cycle. So how long it takes before your graph starts to repeat itself. So like if I were to start right here at 0, 0 and go along this graph, I've got new values, even here, still new values, right? All the way till I get over here, right? At 360, my graph starts to repeat itself. It just looks the same as what was before. That is because it comes from the unit circle, and at 360 degrees, what do we start doing as we go around that circle? We start to repeat, right? We've got 360, we go all the way around, and then we're just going back over the circle after that. So this distance right here would be the period. In fact, it might be better if I label it like this. It's this length right here, period. Because I'm getting it mixed up with the midline right there. Let me, oh no, what did I do? There we go. Okay, so like the period for this would be 360 degrees, or if you're using radians, it would be 2 pi. Okay, so on Monday, we are going to look at how to find these things and how to use these equations for like real life situations. And that'll be the last thing that we cover. Tuesday, we will review. Wednesday, we will have our test. I think there are a couple of you that are going to be out Tuesday for the, no, you'll be back. If you have Miss Brown's class, you'll be back by 3rd period, right? You'll be done by, okay. So you might be a little bit late, but not much. So you'll be fine. It is 2nd period where I'm going to have some